Hey all, it's Parker. I told myself in 2026 that I would start posting video content about the things that I'm currently learning and interested in. And for the past 2 weeks, that's been concurrent programming. I've taken operating systems classes and I know about concurrency, but mostly I'm writing TypeScript in my day-to-day, so it's not something I've ever had to really worry about. But I do write Go from time to time, and I also write Kotlin at work, and so concurrent programming is something that's always in the back of my mind, and it's something that I've wanted to grow more familiar with, more comfortable with, and have a better understanding of. So for the past week or so, I've been reading a book called Concurrency in Go, and I'm about halfway through, and it just touched on the context package in the Go standard library. Now, context felt like something that was very hand-wavy and a bit confusing when I first started learning Go. It's in like every function signature in the standard library, and every time I passed it in, it was like, just trust me, bro, like just pass in this context object, and yeah, it just felt confusing. But now that I have some basic understanding of concurrency patterns, I realize how useful the context package is and the context object. And so today I just want to build up an example use case to show off what context actually is and how these functions are using context. So here I have a basic hello world program in Go. I can run go run main.go and I'll just get hello world. But I want to make a small concurrent application here that is going to utilize the context package. The first thing I'm going to do is create a new function called do something, and I want it to return a result in a channel. So it's like eventually it'll return a result, and let's define what that result is. So it's going to be a struct, and it's either going to have a value, and let's just have it be a string for now, or it'll be an error, and that'll be an error type. And so, yeah, either our do something is going to succeed with a value or it's going to fail with an error. Now in do something, I'll go ahead and make chan result. And then let's have that be, let's just call it result stream. And then we'll return result stream. So what we're going to have do something actually do is it's going to take in a duration, like a certain amount of time. And after that amount of time elapses, we'll have it spit a result into that result stream channel. So the way I'll accomplish this is I'll kick off a new Go routine. And in that new Go routine, the first thing that I'll do is I'll defer closing the result stream so that when the Go routine finishes, the work is done, the result stream is closed. Just a side note, this is a pattern that is showed off in the book I'm reading a lot. So essentially what we're doing here is we are creating a producer function that is going to return a channel that can only be received from. And this do something producer function is going to be responsible for the entire lifecycle of that result stream channel. So that includes closing it when it's finished and writing to it. But after this function returns, no other function, no other Go routine is going to be able to write to this channel. And encapsulating your channels this way, making it so that only one Go routine writes to and closes the channel is a really good way to decrease the complexity of your system and your program. So yeah, we've closed the result stream when this finishes, but what we're going to do now is this Go routine is going to block for a certain duration. So let's just call it duration, and this is a time.duration, and then we'll pass that duration here, and then we will write to the result stream. So right now there's no way for this operation to fail. So we're going to write to the result stream a result and just the success value. So let's say do something succeeded. Okay, great. So now back in our main Go routine, in our main function here, what we'll do is we'll call do something, and let's pass in a duration of time.second, and let's do 2 seconds. So after 2 seconds, we should see that do something succeeded. And I'll also measure the start time.now, and let's keep track of this result. And we'll say here if result.error does not equal nil, we'll do format.println error, and then otherwise we'll do format.println with the result.val, and again printing time.since_start. So now if I run go main.go, we should see that after 2 seconds, the program succeeds, do something succeeded, and indeed we see do something succeeded after 2 seconds here, and this is the success case. Now, one of the problems with do something in this scenario is that right now it must take 2 seconds, and if for some reason the main Go routine needed it to stop earlier, it needs to preempt the do something, then there's nothing really we could do about that. It's stuck doing something for 2 seconds. There's no way to cancel that operation. But if we wanted to add the behavior for the main Go routine to stop do something, then what we could do here is pass in another channel. We'll call this the done channel, and it's gonna be a channel of any, and we're only gonna read from it. Now down here, I'll go ahead and instantiate that channel, and then we'll pass it in here. And whoops, I misspelled it. It should be done. Okay, so we've created our done channel. We've passed it in here. And how are we actually going to make it work? So the Golang concept that we want to use here is the select statement. And the select statement, within it, we can define certain cases. And these cases are each channels that when they unblock, the whole select statement unblocks. So when we receive a value from the done channel, we want to do something. And then we also want a case for that time.after channel. So in that time.after channel, that's again the success case. And in the case that we receive from done, let's just say that's the error case. So we'll have a new result and it will be an error. And then we'll do errors new and do something failed. We could say was canceled. So to explain this Go routine again, it's going to block on this select statement until either the duration passes, in which case it will send to the result stream the success value, or it receives a value from the done channel, in which case it'll send to the result stream an error value. Now, if we run this again without ever sending anything to the done channel, we should see that again, it'll succeed after 2 seconds, which in this case it does. But back in our main Go routine, let's go ahead and kick off another Go routine. And in this Go routine, what we'll do is we'll wait for 1 second, right? So 1 second is less than the 2 seconds it takes for do something to emit a successful value to the result stream. And then we'll write to the done channel in this case. Just an empty struct. Okay, so again, notice here, do something is gonna do something, emits a successful value after 2 seconds, whereas here in our main Go routine, we kick off another Go routine that after 1 second is going to emit something to the done channel. And that will cause this case of the select statement to go off and emit the error value. So let's go ahead and run that. And we should see just after 1 second that do something was canceled, and indeed it was. And I just noticed I spelled canceled with 2 L's, which is awesome. I can run it again without the typo, although I guess it's correct in British English. So maybe I'm British today. And again, just to demonstrate that this is doing what I said it does, if I replace that 1 second with 3 seconds for the error case, now it'll actually succeed after 2 seconds because the error case happens after 3 seconds. Okay, so great. We have now implemented this way to preempt the do something Go routine by emitting a value to the done channel. Now, the way we've done this is a little bit, it could be cleaner. I mean, we had to kick off another Go routine that waits for 3 seconds and then emits something to the done channel. The way we could clean this up, though, is exactly what I was alluding to at the start of the video, which is the context package and the context object. And I'll demonstrate now how it can pretty much one-for-one replace this done channel that we're using. So instead of taking in a done channel, we'll instead have it taken a context, which is context.Context. And instead of selecting over the done channel, we'll select over context.done. Aha, so context.done, there's a done method on the context interface, and it's pretty much exactly what was, it serves the same purpose as what our done channel was doing. So done returns a chan with an empty struct, and there are various ways that we can emit to this channel using the context package and the context object. So let's keep refactoring. We have ctx is context.background, right? And let's get rid of this Go routine, and we'll pass in ctx to do something. Okay, so right now we're just passing in context. We're not doing anything with the context, so we should see that it succeeds after 2 seconds. But just how we kicked off a Go routine to have a timeout after 1 second, we can do something similar with the context object. So there's a function from the context package called withDeadline, and it takes in a context and a time, and it will cancel the context after the time has elapsed. Or I should say rather, the time that you pass in is a deadline, so after the deadline passes. Here, we'll create the context by doing context.background, and then we will pass in a time, which is just time.now, and then after 1 second. Now this returns a context and a cancel function. And for the cancel function, just reading the docs here, it says that you should call cancel when you're done using the context object, just so it can free up the resources. So we'll defer a cancel here. So now, and the last thing I'll do is that not only does context have a done method, but it also has a context.error method. And this error method gets set when done is closed. What we'll see now is an error message from the context package when 1 second has elapsed. So I'll go run may not go, and we see context deadline exceeded, and that 1 second had passed. And again, if I set the timeout, or sorry, the deadline to 3 seconds in the future, then run it again, we'll see that it'll succeed after 2 seconds. So yeah, the context package basically serves as a way to preempt your Go routines, your long running operations, without using like the done channel and having to manage sort of all the things associated with a channel. If we don't want a deadline, but we still want to manually cancel it, we can do with cancel instead. Get rid of the second argument. It still returns a context and a cancel, and we can kind of do what we did before, where we kick off a new Go routine, we block for 1 second, and then we cancel the context. Now, if I run this, we'll see that context was canceled after 1 second. So yeah, the context package is actually super straightforward, way less complicated than I was making it out to be. I think it just requires some background knowledge of concurrency in Go. And to end this video off, I just want to show off the actual context package itself, or at least the interface. It's got that deadline, the done channel, as I was mentioning, the error value. You can also pass in keys and values to context. This is a sort of a contentious part of the context package. It sounds like passing in sort of these opaque keys and values, using context as a map instead of just using arguments to a function. Anyway, I didn't touch on that here, but there are plenty of other resources for that. I mostly just wanted to chat about done and deadline as a case for replacing using a done channel everywhere to preempt your Go routines. But yeah, hopefully this was a simple guide to the context package and the context object. There's really not much to it, and so it's not something you should be afraid of. It's just a tool for you to use. And if you're not having to deal with any concurrency, then you're just going to pass it along and at least have some idea of what it's doing in those functions. Anyway, if the video helped you, please subscribe and leave a comment asking questions. I'm hoping to upload more videos in 2026. So yeah, you can expect to see more of me in the near future. Take care.